is also there on the polling part, which will store it as a text file, and again converting it is a problem one on that. I think Balaji, you can continue.
Sir, okay, sir. Thank you, sir.
Okay, thank you.
Thank you, sir. So good afternoon. Yeah, it's going to be a challenging session after lunch. I'll try to keep it short and sweet, and I'll start from where we left. We were looking at consensus algorithm, and you all know, even though the blocks are getting mined, they need to be validated. How are we going to validate? It depends on the particular consensus what we have achieved for a particular blockchain network. For a blockchain network A, if we have assumed our consensus as a 51%, then irrespective of any factor, only if 51% of the nodes participating in the network accept, then that particular node will be validated. That particular block will be validated. Or if I have some leader and I have given the rights to leader to validate the block, then the leader is the whole responsible who has to approve that block, whether it has to be added to the chain or not. So like this, there are a lot of methods. The commonly used two methods are proof of work. So the proof of work stands for whatever work we have done. We have done the work, we have done that mining work, right? That mining work is known as a proof of work. Another common method is proof of stake. Proof of stake is something where whoever holds the more property. For example, let's assume that out of 100 rupees, I'm the one who is holding 40 rupees. Then I'll be vested with the role of validating the block, because they know, since I am the major stakeholder, if I commit any mistake, then I will be the one who will be affected more. So in that consensus, proof of stake is the one where the person who is holding more number of stake will be the vested with the power of validating the block. This is how the consensus algorithm generally works. But coming back here, we saw what general 1 and general 2. You remember, this is a very famous two general problem. They are planning to attack on Monday morning. This is the city which they are planning to attack. The point is, the assumption is both of them should come to a consensus to launch an attack. General 1 sends the message attack on Monday morning. Assume that the message is broken here. Now what will happen? There will be no reply from general 2. But general 1 will not be notified, or general 1 will not be aware that the message has not, whether the message has reached the general 2 or not. So unknowingly, if he launches the attack, then he will be the one who will be in the losing side. Otherwise, by caution, if he doesn't launch the attack, then still he will be sitting there and he will not be able to do anything. So this particular problem illustrates us the importance of arriving at consensus. So arriving at consensus is not an easy task. Morning again, you may recall, I said about even if the message is not broken, if it is successfully delivered to the general 2, how will the general 2 react? Again, he will send the message to general 1. How will the general, this is the acknowledgement message. Then how will the general 2 know whether the acknowledgement has reached the general 1? He may send a message for acknowledgement. Then what he will do, how will he ensure? He will again send a acknowledgement for the message 1 and so on. So this is a never ending process. We will be never able to come to a consensus if we keep on doing this. So this is just a small mathematical damn old problem which illustrates us the importance of a consensus mechanism which we need to adapt in our blockchain mechanisms. Slightly a bit more higher problem, Byzantine fault tolerance. This Byzantine fault tolerance is also there from 1970s. This is not a new technique. Here you can see there will be 4 generals. One among them is a commander. He is a commander. The others are general. General 1, General 2 and General 3. Their aim is to capture this castle. They are planning to capture this castle. The point here is they have to arrive at a consensus to launch the attack or to retreat. So this problem says traditionally they will be able to launch the attack only if they have 33% of consensus. That is, among all four, if one is an intruder, see the assumption is that one is an intruder. For sure, one is an intruder. If there is one intruder, still they will be able to launch the attack and capture the castle. If it exceeds, if there are two intruders, then this Byzantine fault tolerance will not work properly. And before getting into the nuances of Byzantine fault tolerance, this Byzantine fault tolerance is not only used in blockchain algorithms. See, that is the beauty of this blockchain. The so-called hashing algorithm or the so-called immutability nature of distributed computing or the Byzantine fault tolerance, all these things were damn old concepts which are existing for a long time. But what we are trying to do here is we are trying to deploy them to fulfill the needs or requirements of a blockchain. That is the beauty of this blockchain. Blockchain make use of the existing technologies to perform its task. That's where the blockchain specialty is all about. That's why we call blockchain as an ecosystem. So coming back here, Byzantine fault tolerance can be used as a candidate in any kind of decentralized application. Not only with respect to blockchain, any kind of decentralized application can use Byzantine fault tolerance. In real-time application, Byzantine fault tolerance is used in rocket launching, aircraft maintenance, and so on. So here what they do is, you can understand in rocket launch, for example, if one of the particular sensor, a minor sensor fails, then we cannot make the rocket to dip into a water. We should understand, see, it's more about fault tolerance. You would have heard about reliability and fault tolerance. Fault tolerance basically talks about to what extent we can tolerate the fault. Let's assume that 10 systems are there. We will be able to successfully carry out a task if 4 systems are functioning. Then the fault tolerance level of that particular network is 6. It can accommodate up to 6 fault. Still, it will be able to deliver the task. Likewise, in rocket launching application, if a small sensor fails, then we cannot allow the rocket to fall down from the sky. Likewise, in aircraft maintenance, imagine that our sensor near the window fails. So it doesn't mean that we should stop the plane and get down and it should be landed. No. Still, with the occurrence of fault, still the aircraft will fly, still the rocket will fly. This is what we are talking about, fault tolerance. And Byzantine fault tolerance is used both in this rocket launching and spacecraft applications. Again, I reinstate, Byzantine supports 33% of fault tolerance. So out of 100, if 33 are defaulters, still the system will work. If the count goes to 34, then the system will not work. That is the policy of Byzantine fault tolerance. As per that policy, out of 4 generals, if one is an intruder, it will work. If it becomes 2, then it will not work. Let's see how it is actually understood. You can see here, green indicates attack, red indicates retreat. Let's assume that he is the commander now. He is the commander. He is giving the order for all the generals. He is the intruder. He is the malicious intruder now. These are all genuine people. These 2 are genuine generals. So he is the commander. Commander is now issuing the order attack. So what is he doing? He is anyhow he is an intruder, right? He is a malicious entity. So he is propagating the message as retreat. He is saying it as retreat. Now what happens, since they follow distributed computing scenario, all messages are delivered to all people. So here he is saying attack, and these are all genuine journals. So they will communicate whatever they have received. They say attack. He also says attack, and he says attack. Here it says attack. Here it says retreat. Now see here, with respect to this general, how many greens are incoming? 1, 2. 1 is retreat. So he will go with the majority. He will decide to attack. With respect to this general, how many greens are incoming? 1, 2. There is 1 red. So out of 3, 2 are major. So he is also deciding to attack. This guy, we all know, he is a malicious entity. Whatever information comes, he will be acting opposite to that. So automatically he will be retreating. Now commander has passed the command. Commander has passed the order for attack. So he will also attack. So 3 of them are going to attack. So they will be able to successfully capture the castle. Even though this guy is going to ditch them, still these 3 fellas will be able to capture the castle successfully. This is the scenario of a Byzantine fault tolerance where there is a 1 traitor. Now see, in case there is a condition that there is no condition that commander need not to be a traitor. Commander can also be a traitor. So let's imagine that he is a traitor or a intruder, malicious intruder. Now see, he is saying to attack. See, if he says to retreat, then everyone will know that he is a traitor or he is an intruder. So now he will give a divided opinion. He will ask this guy to attack, but he is passing this retreat message to him. Now see what happens. In this end, he is getting 1 attack, 1 retreat, 2 attack, 2 attack and 1 retreat. So he will go with the majority, that is attack. What is this guy receiving? 1 attack, 2 attack and 1 retreat. So attack is the majority, he is also going to attack. Take this guy. He is receiving 1 attack, 1 retreat and 1 more attack. So 2 attacks. So he is also deciding to launch the attack. So here also, even though the commander himself is an intruder, still the attack will take place. They will capture the castle. Can you understand this scenario? Any doubts?
Yes, sir.
Yeah. Okay. So please understand, this is an example, the traditional Byzantine fault tolerance algorithm, what I'm explaining you. This concept is inherited in blockchain. Don't ask me whether there will be generals and they will be attacking the castle. No, this is the Byzantine fault tolerance algorithm. Equate that to our digital examples. When there is among four entities, if there is one malicious intruder, then still the system will function properly. That is the 33% concept. Now, can you say me what is the percentage upon which the blockchain, Bitcoin blockchain system operates? Morning we saw, I mentioned about a percentage.
51%.
Very good. 51%. Here we are exceeding the Byzantine fault tolerance. Byzantine fault tolerance algorithm talks only about 33%, but here we are ensuring that 51% should be working properly. So the fault tolerance is 49%. If there is fault tolerant to the level of 49%, it will work. When it exceeds 50, then the system will not work. It will get collapsed or it will stop. So this is the understanding of consensus algorithm. Any consensus algorithm or protocol need to encounter 2 challenges. One is attacker scenario. Another one is competing chain. We call this as a competing chain. So consensus protocol need to give an answer for these 2 problems. What is this attacker problem? Morning, what do we saw? We saw in an existing blockchain, an intruder is trying to barge in and he is trying to change the intermediate block. That is, he is trying to change the entry in the intermediate block. He is trying to convert the costly 100 crore property to his name, and immediately the other hashes changes. Okay, it's all fine. We saw how auto correction option comes into effect, how it will be able to restore the original blockchain, and we also saw it in case if someone wants to really intrude and change the values, then they have to capture 51% of the nodes. Actually, this is not node, 51% is hashing power. This you will understand once you go through the sessions. 51% of hashing power. Then they have to do it within 10 minutes. Now you recall morning I showed you the Bitcoin blockchain network demo, not a demo, I showed you the website where the average time for a new block is 9 to 10 minutes. So that's why we say within 10 minutes they have to change. Okay, this story and all fine in case if someone is trying to intrude in between. What happens if someone is trying to add a malicious block at the end of the blockchain? How will we fight? Can you understand this scenario? The morning we
Yes,
saw,
sir.
yeah. So now if someone is intelligent enough to add a malicious block into the network, how come this consensus protocol is able to withstand this challenge? You recall morning itself I said, even though a block is successfully mined, before getting added to the network, it will undergo a validation. See, this is only a sample of validation what I've given here. You can see here, there will be more than 150 type of checks. It will check whether the block arrived has been originated by the valid member, whether it has been mined successfully, whether it has the valid transactions, whether it has followed all the nomenclature which is provided by the blockchain network and so on. So some 150 checks will take place, more than 150 checks will take place for mined block. Please understand, I'm not talking about unmined block. After the block being mined, it will not be immediately accepted into the blockchain. It will undergo 150 plus checks. The block which successfully gets through all this 150 plus filter checks, then it will be added to the particular blockchain. Then only it will be added. Okay, now you can ask me, if someone is trying to insert a malicious block, what will happen? Morning we saw, if someone is able to successfully mine a block, they will get the reward. Likewise, if someone is trying to add a malicious block, then they will be penalized. Malicious block, they'll be penalized. They will be penalized. Whatever amount they have in their Bitcoin, whatever amount they have in their in the form of Bitcoin, that will be reduced. Can you understand this? Are you able to follow what I'm trying to say? Do I need to explain anything again? Are you all clear?
Yes, sir.
Yeah. Thank you, madam. So the second condition is, the first one was a malicious condition. The second condition is competing chain. What do you mean by a competing chain? Again, you remember, blockchain will have different nodes located in different geographical location. Accidentally, this is not done with any intention. Accidentally, if in two ends, for example, this is in again morning Madurai, and let's say this is Coimbatore. In the two ends, the block is getting inserted. These are not malicious blocks. These are valid blocks. Here one block is added. Here one block is getting added. They are valid blocks. This can happen. Am I right? Because we don't know. It is a copy of same chain, but unknowingly in two ends, the valid blocks are being added. Now, which block will be retained and which one will be left? That we need to arrive at a solution by using the consensus protocol. What will we do is, you can see here, this light brown block and purple block. This is a purple block. Both are added in two different ends and they get added to the chain. You can see here how many number of nodes that light brown block is able to reach. Light brown is able to reach how many number of nodes? 1,
Three.
2, 3, 4, madam. Am I right? 1, 2, 3, 4. And purple block, how many nodes is it able to reach?
2.
2. So this is 4, this is 2. Here the answer is very simple. We go by Nature's phenomena. Whoever has more reach, they win. Whoever has more reach, they win. So who has more reach?
Brown block will be added.
Yes. So the brown block will be retained Unfortunately, this purple block will be left out. This purple block is not a malicious one, understand. This is also a valid block, but due to some internet connection or due to the connection nature of connection, the brown block, the light brown block was able to reach to more number of nodes in the network. So that will be retained, the other one will be left. So the one which are left, I think it is, the header is blocking it. Okay, I'll write down here. So the one which is left out is known as a orphan block. You can see here now the purple block is replaced by the orange block. Now it is called as a orphan block. You can see here the purple one is called as a orphan block. Can you see here? This becomes a orphan block. Now what will happen to an orphan block? Whenever a block becomes an orphan, the transactions inside that block will go back to the mempool. They will go back to the mempool. They will stay there. Again, these transactions should be picked up by some other block. Can you understand this logic? Do you have any doubts? Please do say me, I'll clarify. Any doubts? Do you have any doubts here?
Sir. No, sir.
Okay, madam. So this is what will happen at orphan block end. So orphan block will be no more entity. It will get dismantled, and you all know block is nothing but the entity which is comprised of more number of transactions. All the transactions which were picked up in the orphan block will get released. They will go back to the mempool and they will reside there. Shall we continue? I hope you all of you are clear. Okay, now you can see here, this is what I was talking about. The consensus, commonly used consensus algorithm or proof of work is used in Bitcoin as well as in the Ethereum. Proof of stake is now slowly they are trying to use in Ethereum. Proof of authority, proof of burn, proof of life, elapsed proof, and distributed Byzantine fault tolerance proof. Lot of proofs are there. So the proof of work is nothing but whenever you mine the value successfully, that is what is called as proof of work. You remember in the morning we saw mining is nothing but finding out the current hash value by referring to the previous hash value. This job is called as, the mining is called as proof of work, and they will be rewarded for this proof of work. Proof of stake I already explained. Those who have more number of stake, they will be the one who will be vested with the mining operation. So almost I have done with the concepts of blockchain. Do you have any doubts? You can clarify with me now. Now hereafter I'll go to type of blockchain and applications of blockchains. Do you have anything, any specific doubts?
Sir.
No, madam, you don't have any doubts. Okay,
So what is the specific softwares we should have for creating the blocks?
Okay, madam, I'll show you now. Anyhow, I'll be talking about that, madam. Next, I'll be talking about all those things. So blockchain structure. So the definition of a blockchain is the use of mathematics to create a secure distributed ledger which enables transactions without the need for third parties. That is what we have seen now. And we have different type of blockchains. What are the different type of blockchains? What is the need for different type of blockchain? Cost effectiveness and quick turnaround, and reducing the redundant work, And the third one is dependency on huge servers. Morning we discussed about redundant works. So there is a way for reducing the redundancy by using by classifying the blockchains into different type. First type, it is called as public. I mean, the types of blockchain are, the first one is public, second one is private, third one is consortium or federated blockchain. We will see. Public blockchain, as the name suggests, it is open for all users. Anybody can participate in the public blockchain. Nobody is in charge here. Anybody can read, write. Auditing is not extra term, but anybody can read and participate in the open network. Copy of ledgers. All the users maintain copy of ledgers. This is the example we saw in the morning. Even Bitcoin or Ethereum or public networks, you will see. As there is no dedicated in charge, decentralized consensus mechanism like proof of stake and proof of work are used here. The common examples are Bitcoin, Ethereum, Dash, Lisk, Factom, Blockstream. These are all the common types of public blockchain. Private blockchain. For example, you want to create a private blockchain for your college. What you can do is, private blockchain will be more operating like a distributed database. It will be more resembling your distributed database. You can see here, it is not decentralized like public blockchain. It is not decentralized. All permissions are kept centralized to an organization. This type of blockchain enables an organization to create its own currency. Here, there will be a centralized authority who will be vested with the power of writing or editing or auditing. The consensus or mining rights are achieved by in charges. That is, the centralized in charge or the leader or the central authority is the one who will be in charge for performing the mining and other validation operations. Central authority. Main drawback, we will be losing the beautiness of decentralization, and the examples are multi-chain and block stack. Consortium is a combination of both public and private. For example, again you can take Mahindra Engineering College can have a private blockchain. SSN can have a private blockchain, but we all can participate in a consortium, the blockchain which is created by Anna University. So for Anna University, we all will be nodal points. Within Mahindra Engineering College, whoever is part of it, they can exchange information within the private blockchain. Within SSN, people can exchange information, wherein all the people or all of us who are part of the Mahindra Engineering College cannot participate directly with Anna University. There will be one representative who will be the more like your controller of examination. He will be the point of contact for interacting with the university. So that is a consortium example. The commonest example are Ripple, R3 and Coda. Coda is also a federated blockchain, and these blockchains are gaining popularity in the recent time. So if you are really interested to learn, you have courses for Coda. Coda certification is available both in Udemy and Kerala Blockchain Academy. If you really want to prosper, you can look out for these courses. So now answering ma'am's question, what are the software or framework we need to use or know to deploy or use blockchain? See, the frameworks are, Ethereum is a public one, you all know. Hyperledger, it is a very, very important component. Hyperledger is a enterprise blockchain. Okay, so Hyperledger is a enterprise blockchain. So when I say enterprise blockchain, the meaning is, this is the blockchain which is used by companies. If you look at any company, most of the companies will be using Hyperledger for developing a blockchain projects. Hyperledger has a lot of types, Fabric, Composer, many eight types are there in Hyperledger. Probably if you have a session, you will come across. Hyperledger was initially introduced by Linux Foundation, but now it is under the ambience of IBM. IBM is the owner of IBM Hyperledger, but still it is open source. If you are interested to work on Hyperledger, you can work. And IBM also has given provisions through Watson. IBM Watson also has black box implementation which you can use for developing your blockchain projects. Multi-chain is a simulation and actual network which you can use. Hydra chain is used for federated blockchain. Ripple R3 Coda, you know. Open chain again is a open source which you can rely. IOTA is a tangled blockchain. We call this as a tangled blockchain. I'm not going to talk about this here. It is a different, altogether a different concept in blockchain. Here we call this as a blockless blockchains. So if you are interested, you can look into IOTA. IOTA is a new architecture or a framework. IoT acyclic graph. So programming language. What programming language should I know to develop a blockchain? You can use C++, Java, Python, Ruby, Solidity, Go, C#, JavaScript, Simplicity, Rust, Rolang, CX, Viper, Scala. So here C++ is okay, but I would recommend you to go for Python or any scripting language. The front end, you need to know a front end, preferably a scripting language. You should have a basic knowledge of backend. Any SQL, MySQL will do. So this scripting language, you can consider Python or Ruby or Solidity. Solidity is a Ethereum compatible language. The entire smart contract in Ethereum is developed using Solidity. You need not to install anything for Solidity. remix.ethereum.org. If you type this in browser, you will have the virtual compiler for running the Solidity program. Go is again a very upcoming scripting language. Go is becoming a recently very famous language, and Go is considered to be a potential threat for Python. JavaScript, you can think of using JavaScript, AngularJS, Node.js. Simplicity is also a new language. Rust is a new language. Rolang is a new language. And Viper is again a framework which you can also use along with this remix. Scala is used for scalability. When you are bothered about scalability of blockchain network, then Scala is a network language which you can use. Scala is also an open browser language. You need not to install anything. You can directly type and you can execute your programs. These are all the different utilities which you can look if you are really interested in blockchain. You can see here GetH. It's a library, Ethereum library. Goerli testnet. Testnet will allow you to play with the Ethereums. They are not the real blockchain, but they will give you a scenario of a blockchain. And Hyperledger Caliper, it is a benchmarking tool. Ganache, you can use Ganache for performing the client, server client operations. Fiddle, Scripter, Status, Embark. MetaMask is again a very important application. I'll not work with MetaMask because I don't have a time. I'll just show you how can you use MetaMask. 1 minute. I'll just show you the feel of it, how it will look like. Can you see, this is my mail ID. Can you see this? Can you see this symbol?
Yes, sir.
Can you see this? This is an extension. This is an extension which you can add with MetaMask. And I have used a Rinkiby testnet. So I'm not going to do anything with that. This is only for a demo, only for showcasing. So you can also install it as a Google Chrome extension. Possibly I'll mail a PPT content to Sir. By following that, you'll be able to generate a Ether. What you can do is you can create a test network. By using a test network, we will be able to generate Ethers. Okay, so that is the use.
MetaMask is there, Balaji, for their session.
That's okay, sir. Then they will learn from MetaMask.
Yeah.
Because since they are going to study Ethereum, I think MetaMask will be explained to them. So what you can do is you can post a tweet in Twitter. You can copy it in a Rinkiby test network. It will generate a Ether coin for you. You can communicate. You can transact that by using a MetaMask. That is a separate demo which normally we do when we are doing for cryptocurrency. So just to give you feel about MetaMask, that's all. Probably when you are doing it, you will understand. So parity, drizzle, remix, I said. Remix also, I can also show you the remix screen. You can type remix.ethereum.org. When you type this remix.ethereum.org, you'll be getting a remix IDE. This is a web-based IDE. I'll be using the previous version. Okay. So you can see here, by default, there will be some programs. I have not saved any program here, but I have done some programs. We do some projects by using this. This is a ballot program, e-voting concept. You can see it will also give you the compiler version. You can type the program here. You can save the file. For example, if I want to create a new file, I can save it like untitled.sol. I can type. It will be more like a JavaScript, but reverse of JavaScript. So you can also look into it. So this is remix.ethereum.org. So probably when you are doing MetaMask, we can write a code here. We can integrate MetaMask and the Ethereum transaction. By writing some 2 or 3 lines, we will be able to integrate Remix and MetaMask through Remix code. When I compile the code, automatically MetaMask, the amount whatever I have stored in the MetaMask will be transferred to the Ethereum network. Probably you will all come across those sessions when you have okay. So that is it. And research challenges. Being we are all faculties. If you ask me what are the research challenges available in blockchain, security still is a research challenge. You can think of using alternate for hash algorithms. We came up with a paper. One of my scholar is working on a chameleon based hashing algorithm. We have published that paper. It is almost accepted. We are waiting for its publication in wireless personal communication. What we have done is we have proposed chameleon based hashing algorithm for e-governance. I have also proposed this to Tamil Nadu government. I'll say you all those stories later. So you can think of using some other algorithm. What are the other algorithms you can think of? You can think of quantum resistance. You can think of using quantum resistance. You can think of quantum cryptography, ring signatures. These are all the other candidates. Ring signatures. These areas you can work on. Privacy is maintained. See, actually, in any Bitcoin network, your name will not be revealed. What will happen is, you'll be given a public key. From public key, a private key will be extracted. And from public key, they will also extract a Bitcoin address. So all your transactions will happen through only this Bitcoin address. Even if they are able to crack your Bitcoin address, they will be able to go to only your public key. From public key, if they still want to know your private key, they have to crack again. So this is the layer of security which is used for maintaining the privacy. Okay, privacy is completely maintained there, but even then you can still work on the privacy side. For example, if you feel like you want to create more privacy, then you can work on it. Scalability is a very big challenge in blockchain network. We are not able to achieve scalability. For one example, I'll say you, with respect to financial transaction, a Bitcoin, the capacity of the Bitcoin is only 10 to 30 transactions per second. Whereas your our typical Visa or MasterCard does 2 to 3 million transactions per second. Then now you imagine what is the level of scalability we have with respect to blockchain, with respect to financial application. So scalability is a huge research. If you are working on it, you can get into it. lot of scalable blockchains are proposed. We call that as a mint concepts in blockchain. You can research and find out. Consensus algorithm, almost 14 consensus algorithms are there. Still, you can also come up with new consensus algorithm. Depending on your nature of application, new consensus algorithms can also be proposed. For example, what consensus algorithm we can use effectively for healthcare applications? That can be thought and that can be used. Any doubts here? Okay, if no queries, then I'll proceed. So now I'm going to show you what are the companies and startups which have already started creating an impact in blockchain. So these are all the companies. You can see in authorship, in real estate, in healthcare, in enterprise, government, retail, media. These are all the social network. These are all the places where the people have already started working on, or people have started already using blockchain. One example is, I'll show you one browser. Okay, there is a browser called Brave. Morning we discussed about this, right? You recall I said if Google closes down, what will happen to our data? We will not be able to use Google. There is a browser called Brave browser. You can also try that, brave.com. So the beauty of this Brave browser is it is completely developed by using DApp concept, that is distributed app. There is no single owner here. If somebody wants to close this Brave browser, they have to get the consensus from more than 51% of the people. This is only again assumption. There are rules for this, but imagine that only Brave can close down its operations only if more than 51% of the people agree for it. Otherwise, the Brave cannot stop its operation. This is a live example of blockchain where Brave is a browser which is developed by using the concept of distributed apps, that is DApp. And there is one more one. Currently, I think it's not live. Steemit. Steemit is again a equivalent of a, you can see here, Steemit is equivalent of your Twitter. It is equivalent to your Twitter, but it was completely developed by using the concept of blockchain. Okay, if you go and look into the Wikipedia, you will understand Steemit is completely developed by using a blockchain concept. There is no single owner here. You can see here, it will resemble more like our Twitter. So these are all the live examples where blockchain is already in place. And coming back here, so these are all the other enterprises who have started using blockchain. You can see here, Apple, they patented the blockchain for time stamping, and Facebook also came up with the cryptocurrency called Libera. Libera is their new cryptocurrency which they launched before 2 months. It is also making a wave in the market. So Libera, Google uses blockchain technology to enhance their cloud services. And you can see Toyota uses it, British Airways, Walmart, already we have seen, Samsung, FedEx, Nestle uses this. Maersk is one of the largest supply chain company in the world. You would have seen the very big trucks will be sailing in the road in name of Maersk. They are the largest German-based logistics company. They use blockchain. Governments, if you talk about government, Dubai government started using blockchain from 2016 itself. So they have framed a committee and they have decided to use blockchain in the areas of healthcare records, shipping, business registration, and preventing our conflict of diamond. See, the point is, diamond tracking is a very, very important application of a blockchain. There are a lot of projects which are going on where they try to track diamond. So what they do is they tend to take blockchain. By using blockchain, they track where are the places where the diamonds are located. If they move from one person to another person, that will be tracked by using blockchain concept. Not only diamond, there are very famous use cases where they also track wine. The age of or time of wine is tracked by using blockchain. You can also track car. Everything can be tracked by using blockchain. But when I say blockchain, it is not only by using blockchain. There should be some RFID reader or there should be some sensor and so on. So Estonia, the Estonia government, it has partnered with Ericsson on involving a new data center to move public records to blockchain. And Estonia is another country which has already started e-voting, and they also use blockchain to award citizenship to the people. They are the first country in the world to give digital citizenship or e-citizenship. South Korea, Samsung is the major player. Excuse me. Samsung is creating a blockchain solution for the South Korean government, which they are planning to use in public safety and transport applications. And UK department is, they have not completely turned into blockchain, but they are contemplating use of blockchain by introducing some coins. Some coins partially, not completely, they are using it partially. Sorry. So that is UK government. Now, can you guess? So before talking about this, can you say me what are the state governments in India which have any guesses, like which government in India started using blockchain first? Any guess?
Tamil Nadu.
Tamil Nadu, okay, not right.
Delhi,
Kerala.
Delhi, sir.
Kerala is one of the
Delhi.
Delhi, no. Kerala is using a blockchain to its fullest efficiency. They have a lot of setups, but they are not the first.
Telangana.
Very close. Which one is very close?
Andhra.
Andhra, yes. Andhra Pradesh was the first ever state in India to use leverage blockchain. Under the leadership of Chandrababu Naidu, when he was CM, he was the one who used smart contract for real estate registration when he introduced that Amaravati city. So smart contracts were introduced by Andhra Pradesh, and the other governments which use are Maharashtra. Maharashtra uses blockchain for storing their school children certificates, particularly 10th and 12th certificates. And the other one was government of Rajasthan. Rajasthan was the first state to store electronic health records by using blockchain. Blockchain. This was also the previous government, Vasundhara Raje's India government. They used blockchain. Then comes the other state. Kerala has taken a very big initiative. And Sir was saying about Kerala Blockchain Academy. I did a certification from Blockchain Academy. They run a course. You have to take up the course and you have to complete the test. Then you'll be given a certificate on Certified Blockchain Associate. I am a Certified Blockchain Associate. And then comes Tamil Nadu government. Tamil Nadu government has taken an initiative called Nambikkai Inayam. This is a part of TNEGA initiative. Now probably people will know what is TNEGA. When I used to give a talk before 3-4 months, nobody will understand what is TNEGA. Now you all would have understood about TNEGA. If I want to summarize, they are the one who give you e-pass. So don't ask me e-pass, they have removed it now. So this was the section which was handling the e-pass. There is a separate division for blockchain. What we do there is, I'm also one of the member. We also contribute there. What we do there is, they are coming up with the common framework for blockchain applications across different Tamil Nadu government initiatives. We will be launching a common blockchain framework, which can be used by educational sector, real estate sector, or transport, or any sector pertaining to which are interacting with the government. They'll be free to use this framework. That framework is named as Nambikkai Inayam. In Tamil, we call it as Nambikkai Inayam. So that is being initiated by TNEGA. Hopefully, it will get launched after this COVID situation. Otherwise, it would have been already launched. So this is the initiative from Tamil Nadu government. It is also clubbed with smart city applications. So this Nambikai name will be part of all smart city applications. So who are all the members? Academically, IIT, Anna University, and SSN. From SSN, I'm the one who is representing. And apart from this, there are a lot of startup companies. And apart from this, there are a lot of government agencies and government representative. We all come together, we meet, we decide the policy, we implement, and so on. It's all give and take. Teamwork. So if you want to learn blockchain, these are all the venues where you can learn blockchain. So these are all the places where you can look at. These are all the way you have to learn. And this is the overall structure, how you should learn blockchain. So now what I'll do is, I'll say what are the places where you can learn blockchain. For say, I already mentioned about Kerala Blockchain Academy. So always you can rely on Kerala Blockchain Academy. Other than that, Udemy. Most of my slides are from Udemy. Third, you can probably all know about Coursera, Udemy, FutureLearn, edX. Then you have Upgrade. Upgrade as a PG diploma program in blockchain, but it will cost you around somewhere from 1 to 2 lakhs. This is advisable for people who are planning to make up your career by using blockchain. They offer certification in collaboration with IIIT Bangalore. And there is one Talent Spirit offers a blockchain certification in collaboration with IIIT Hyderabad. You can also look into that. Other than this, you have Edureka, IntelliPath, Simply Learn. These people will charge you somewhere around 15K to 20K. Other than this, there is one Bits Pilani, they call it as WILP. I'm also a guest faculty for blockchain with respect to Bits Pilani. So WILP is the scheme under which they offer blockchain certification. You can also look into it. And most commonly, TEDx talk on blockchain. Finally, none other than YouTube. Google. These are all the different avenues where you can learn aspects of blockchain. There are 2 universities which offer you MTech program in blockchain. And again, I forgot to say this, NPTEL has a very good course on blockchain. The NPTEL and IBM, they collaboratively offer. NPTEL and IBM course is very good in blockchain, but it will be too elaborative. You have to look into it. Other than this, cognitive class.ai. Here you will find all IBM courses, not only blockchain, other courses will also be there. And you can also look into developers guide of IBM, where you will find lot of open source code for different applications, including blockchain. So these are all the places where you can rely or you can look out for blockchain. And that's it. If you have any doubts, you can clarify with me. And I promised you to show some other slides. I'll just traverse. I'll not be showing you, I'll not be talking about them. I'll just show you what it is. Just a minute. I'll open up the slides. Yeah, 1 minute. I'll show you the slides. Yeah. Sure. Are you all able to see the slides? Yeah, this is a cryptocurrency slide. You can just see, have a look at it. Most of the concepts what we discussed today will coincide with this also. These are all halving principle, which I said. This is the block frequency, you know. Bitcoin, I said 10 minutes. For Ethereum, it's only 15 seconds. For Ripple, it's only 2.5 seconds. This is the frequency of block addition. And mining, how a mining difficulty is adjusted. These are all the large mines. I said about mining happens in China. You can see here, these are all the places where mining actually takes place. Ratio of mining, how it takes place. What are the hardware? And what is the percentage of mining? I said 80%. Nonce range, how are we going to vary the nonce range? How timestamp play a role in creating the hash value? Mempool, morning we discussed about mempool. This is how the transactions will be stored. They will be picked, they will be moved to the blocks. This is how they will be moved to the blocks. You can see here, the transactions will be there in the mempool that will be moved to the blocks. And this is how the mining operation takes place. These are all the hardware resources. ASIC is one such integrated circuit architecture which supports mining. How mempool works, a different mining with the block transactions, getting inserted. Orphan block, we saw orphan block in the morning. What is 51% attack? Well, these are all the transactions. This is how the cryptocurrency transactions will take place. So these are all some examples how a transaction takes place. This is how the wallets will be stored. Private key, public key. I said about this. This is one new concept, SegWit. This is how it is. So once you enter, you will be provided with the private key. From your private key, by using easy digest algorithm, they will generate the public key. From public key, they will apply the SHA-256 and generate the Bitcoin address. This is how your address will be generated. So this is the process, multiple private keys, and so on. So these are all some additional features. So I'm done with. If you have any doubts, you can ask me. No doubts?
PPT?
No, I'll share the PPT with the organizing team. I'll share with Kannan sir. You can get it from there.
And Kannan sir maybe request to share the PPT?
Yeah, surely we
No,
will
I
share
think
it,
they will
sir.
share. They will share because they are going to conduct an exam, right? So probably they will share you the resources, sir.
Surely we will share that.
Yeah, we will share you. They will share you.
Okay.
You can go to YouTube. If you want to develop see, Python is a very good starting language which you can rely to start your journey in blockchain. Go to YouTube, type a blockchain in 5 minutes or 10 minutes. You will get an open source GitHub code. You can run it. You will see how you can generate a Python. How can you generate a blockchain? From there, you can start. It is quite easy. You can also easily do it. Any other doubts?
Thank you, sir.
Thank you. Thank you.
Thank you, sir. Thank you, Balaji. I will post the link in the WhatsApp as well as here. So the attendance for the session 3.
So once again, I thank Kannan sir and the management principal, the executive director and management of Mahindra Engineering College for giving me this wonderful opportunity to